Hi, and thanks for watching this two-part demonstration in which I will be discussing some of the various applications of Flownex Simulation Environment in the mining industry. Energy optimization in the mining industry can provide significant returns, and being able to analyze mining subsystems reliably is vital if you want to achieve the maximum potential savings. Flownex provides users with the ability to easily model various temperature and fluid-dependent systems in a way that can simplify complex mining operation, increase safety, and improve efficiency. Some of these systems include mining ventilation, in which just a few of the possibilities are being able to calculate required fan power to circulate air through a mine, being able to calculate wet bulb temperatures and relative humidity with heat loads, cooling, and pressure as inputs, or assessing flow path modifications to an existing system. Complex compressed air networks can also be modeled that contain compressors and multi-stage compressors where large volumes of compressed air are required. One can also size pipes to achieve required compressed airflow or design the supply to pneumatic machinery. Flownex is also capable of modeling water reticulation systems where you can determine pressure and support loads generated by pump trip, water hammer, size pump or spray nozzles to obtain even flow distribution, or minimizing pumping life cycle cost. Flownex also has the ability to model slurry systems which are applicable to mine backfilling, ore transport, and ash transport. One of the examples I'm going to show you is an underground mine ventilation system. Here you can see a schematic over which we will create a Flownex network. We have air at ambient conditions entering the inlet of the shaft. It then proceeds down the tunnel until it branches into the different mine levels. The air is forced through the system by these ventilation fans at the outlets. The network also has a refrigeration system comprised of a cooling water pipeline that cools the air through heat exchangers. It is necessary to maintain the air temperature at a level that is acceptable for humans. One of the benefits of Flownex is the ability to model the ventilation air as an air-water mixture to account for the relative humidity. The humidity plays a significant role in heat transfer, and therefore being able to account for it ensures accurate results. If I open up the page on which I've created the model and zoom in, you can see the various Flownex components used. These include the ventilation duct component, to which we prescribe geometry and losses. We also have fan components where the performance is determined from manufacturer data. Down at the bottom of the page, we have our cooling water loop, where water is pumped from a reservoir through a fin-tubed heat exchanger to cool the air in the air loop. Any result data can be transferred to a Excel spreadsheet. In this case, we've performed a summation of some of the fan and heat exchange results. The spreadsheet results can then be reported to the network page up here, where you can see we have calculated the total underground heat load, the refrigeration power, and the ventilation fan power. For more examples of how Flownex can be used in the mining industry, please watch part 2 of this Flownex mining system applications video. If you are interested in learning more about Flownex Simulation Environment, email, call, or visit the website and set up a discussion with our technical staff at PADT.